Hello, welcome. So I'm Kelsey, and this talk is kind of has a weird title: Kelsey, Kubernetes, and GitOps. Um, I think you would think those three things go together, given my status in the Kubernetes community. But if you really want to understand Kelsey, you kind of have to understand the whole person. We like to label ourselves technologist, and just like many others, I've used many labels over my career. But the first label I've ever had, um, like many people, I've worked in fast food, specifically McDonald's, where you get the purple hat and the shirt to match. You come home smelling like French fries and whatever they fried it in. And a lot of my work ethic, a lot of my maturity, this nature of being a professional started for me around the age of 15. And there's a long trajectory between those humble beginnings to the person you speak in front of you today or commit to your open source or your favorite open source project. And a lot of us try to figure out what's the success behind it. And I don't have a lot of answers, but I know I've been on this marathon for a little while now. And there's a big checkpoint in my career. I remember getting my first like real corporate job, the one where they make you wear slacks Monday, Tuesday, Wednesday, Thursday. And then on Friday, if everything turned out okay, you'll get to wear jeans. And it was a financial services job. And I remember I was a system administrator, just learning things like Python and all of this automation stuff. And it's really when I leaned into ops big time. This is when outages and production really mattered a ton. And I remember one of our outages, we're sitting in one of those war rooms. And for y'all watching this that have never been in a war room, think about a very small office space with a bunch of chairs lined around, and everyone's on their laptop, sometimes pretending that they're actually working on a problem, even though they don't know what's going on. And I remember we're taking longer than normal to resolve the issue. And the company I work with, they process credit cards, the things you keep in your wallet. And they also process the EBT cards. So for people that are getting assistance from the government, they have these plastic cards. And the reason why they give them those plastic cards instead of this different form of money is there's a lot of pride and dignity and convenience being able to swipe and pay for your groceries. So during this outage, guess what? Those cards don't work. And I remember the CTO walking into the room, and I'm not sure if everybody was taking everything super serious, and maybe I wasn't as focused as I should have been. And I remember him walking into the room and he told us really impactful story. And he said, while we're trying to figure this issue out, we have a customer that's been going up and down the groceries aisle, basket full of groceries. And maybe this person has their kids with them. And they're in this checkout line and they're about to go next. Now it's their turn. And all they have is this EBT card. And they go to swipe it to pay for their groceries that have already been rung up, neatly placed in the bags. And the EBT card doesn't work. And here we are sitting around this room believing that we have all the time in the world to resolve the issue. It's just another outage. We'll restart some servers and eventually the system will come back up. And he explained to us that unlike a lot of our other customers, this person doesn't have another credit card to go to or another form of payment. If that card continues to decline, then they're going to be stuck, or the most embarrassing thing, having to put all of those groceries back and then leave home or leave the grocery store empty handed. At that particular checkpoint in my career, I kind of understood that there's a lot more than just writing scripts and throwing them at servers and hoping they work. We need better tools. We have to take the situation a little bit more serious, start to understand things like SLA and building resilient systems, and also figuring out what the hell's going on. Why do so many of us fly blind in production and in some cases laugh and joke about it? The systems that I grew up on, they were just like these black boxes that we owned. Even though we could log into them, most of us didn't even know what was running or how it ran. We just knew if you restarted enough, it would eventually work. We always think we have all the time in the world. And I remember a lot of people telling me, success is measured in time. I remember getting an award like top 40 under 40. And I always thought to myself, it's like, why is there a time limit on this kind of thing, right? Why is there not more opportunities for success that have nothing to do with your time? The truth is there is no time limit. So what I'm going to do right now is I'm going to share my screen. And this is a very interesting number. If you're using GitHub, you may be fascinated with the number of GitHub stars. Apparently, if you get over like 100 GitHub stars, you can probably raise an A round in Silicon Valley. So those numbers do have meaning. But this number on the screen, 1 hour, 59 minutes, and 40 seconds. If you pay attention to the sporting world, this is the current world record for the fastest human being to run a marathon. Most people can't run a single mile in an hour and 59 minutes. But Eliud Kipchoge, he did it. And we tend to put the person who crosses the finish line first in the foreground. Look at this picture. Notice behind him, all the other runners are cheering. That seems a bit odd. It's supposed to be a marathon. That's like a race. Winner take all. There's only one first place finish. But the people behind him, if you watch this, if you watch what happened, the people behind him are also world-class marathon runners. In this picture, you see 8 people in a peloton formation. You can see birds fly like this as well. The whole goal is to protect the runner from any wind resistance and help him keep pace. There's about 30 other world-class runners in this formation. All of them are taking turns. So maybe you run a few miles and maybe the top 2 guys switch out and the other 2 join in. Now, any of the 30 who've been training for months to help them break this world record of a person running a marathon in less than 2 hours, something we didn't think was humanly possible, they all decided that it was his goal and they would be the supporting cast. And they stayed in this formation to perfection, switching in and out without slowing him down. Now, if you ask vendors, how does this work? Maybe we don't talk about the human beings and their upbringing. Maybe we don't talk about all of the practice. Depending on who you ask, maybe if you ask Nike, they would say, it's got to be the shoes. Honestly, I've never met anyone walking around saying that they wanted some Eliud Kipchoge's. They look great for running marathons, but I don't know if you're going to be rocking these to any sporting event. So the truth is, it's the humans that should be front and center. Today, we're going to be talking about Kubernetes and GitOps. And the thing that kind of depresses me a little is that we tend to put all of these tools before the humans that use them. When you think about Git, it's one of the world's best collaboration tools for writing software. And GitHub is where we all meet and collaborate. But it's the people that make all of this work. And when people think about Kubernetes, they want to hyper index and hyper optimize on containers versus this other thing. And you could do that. You can click on all the Hacker News links and have about 10,000 tabs in your web browser. But if you focus on the technology, I don't think you'll ever get it. What we've been doing with all of these platforms is serializing the way we work. There's been a lot of ideas over the last 20 years, and a lot of them have been serialized in Kubernetes. That's the gist of it. I know people want it to be more complicated than that. There should be a series of best practices. Hell, I even wrote a book about it. But the truth is, there's just practice. And as we learn, we'll contribute to those things. If you have a clear goal, if you know what you're trying to do, maybe you know where the finish line is, you can actually bring in all of these people and all of these tools, and they should be aiding you to go faster than you can by yourself. Now, Eliud Kipchoge, he is a world-class marathon runner. He's never ran the marathon in less than 2 hours. He's gotten close, but he's never been able to do it on his own. And sometimes because he's the only one in front and there's no one there to push him. But with this setup, it changed the game. And if you do it right and you keep these kind of North Stars clear, then I think it makes it much easier to understand how all the technology comes together and the people around it. You can wrap that around you and then use it to push you forward. That's the way you got to think about this. If you want to understand GitOps, you got to understand the why. Why are you using it? What's important about it? What's the Peloton formation you're trying to build around you? And is it designed to help you go faster? Or are you just doing stuff because people said it on Twitter? So now we're going to jump into kind of this live demo about how all of this works. So I'm going to switch over to my screen now, but I want you to keep that thing in mind. We should be using these tools to augment what we're doing, not become the whole thing that we're doing. So one thing we have to think about is, what is our actual goal? Most people write software to put it in the hands of their customers. So in this case, we're going to have a very simple app, because what I want you to do is focus on the actual workflow. That's what this whole GitOps thing is about. What type of application can you deploy? I don't know. What kind of applications can you write? So you see I'm rocking that new dark theme. Maybe this is going to be the new trend. And I just have a simple app. It's called Hello Universe. And as a developer, if you put your developer hat on, you have some very specific goals. Your goal is to write code that hopefully works, and then deploy it to the proper environments. And then you should be able to hit an endpoint and get some results. That's the goal. I'm going to show you what that goal looks like when in practice. So basically, I'm here on my command line. And if I run curl HTTPS, and it's called Hello Universe, and then I just have it running on my hightowerlabs.com domain. And there it is, it works. And currently I have version 1 running. So now what is all this GitOps hype about? Why is it going to change the way you think about things and work? The honest truth, it shouldn't. If you think about the way you write code today, if you're a developer, there's a big chance that if you're watching this talk, that you're already using Git. Think about it. When you write code, you tend to make a few commits, and then you push it up. You can run that binary locally if you really wanted to. I can do something like Hello Universe. I have this binary that's on my machine. I can run it locally. And if I were to go to another tab and call curl on localhost, the thing you expect to happen should happen. I could hit this on port 8080, and there we go. That's pretty straightforward. And then you push your code to some repository. But here's the thing. If you really want to know how this works, I think one of the best examples that I've seen online is probably to the people who coined the term, Weaveworks. They coined GitOps. And the whole goal behind GitOps is that, imagine if we were to able to use the same development workflow for managing infrastructure. But here's a twist. We've been doing this for a super long time. A lot of people will look back to like Puppet and Chef and Ansible, and we wrote a lot of code back then. And yeah, a lot of us checked into version control. So what's new about this? This looks like the same thing we've been doing, and someone just came up with a better name for it. That's probably true. And they raised a lot of cash behind it. But the ideas are solid. Why are they solid? Well, there's a twist here. Given Kubernetes and the way it works, we now can start to treat infrastructure as data. And a lot of people say, nope, I thought it was infrastructure as code. Yeah, you can write a lot of code, but code has some other issues to it. One, you need something that understands that programming language in order to write that code, parse that code, validate that code. And those tools exist, don't get me wrong. But the idea that if we can write code or config as data, maybe we can simplify this. I know what you're thinking. Oh, more YAML. Look, YAML ain't that bad. Stop complaining. It's readable. You can modify it, and we can run things like static analysis without having a compiler or something that can parse that language. An overview, this is what it looks like. I know people get this super complicated. I know a lot of people will talk about CI/CD and pipelines and deploying 2 trillion times a day, even though they don't have a reason to deploy 2 trillion times a day. It's something we brag about at conferences. Don't worry, it isn't real. The truth is, it's all about the workflow. How you encapsulate that workflow, well, that's going to be up to you. Look at this diagram. As a developer, on the left side, you write code, it goes into a version control system, and then ideally you're going to produce an artifact. So here's where this Kubernetes connection comes into play. Kubernetes requires a container as the price of admission. Oh, I know what you're saying. Oh my God, I got to build a container. This is the hardest thing in the world. Oh, it's going to take me 7,000 years to learn how to build a container. And I ask people like, wow, have you even tried? Like, seriously, have you tried to build a container before you start freaking out? Think about what's required, right? If you know how to build your app locally, right? Like these are the same kind of commands I would put in a build script. Then in my case, I keep things super simple. I build my app the same way I normally do. And then based on the results here, this hello universe binary, I simply copy it from my build step and then package it. We're really talking about glorified tarballs, but they're really powerful. But they are very similar to using things like Ruby gems or a warfile if you come from the Java world. You got to package software in something. Why not pick something that's super universal? That's the selling point. If you don't like Docker files, there are other tools that can build container images. Get over it. Once you do, then the world kind of opens up to this other thing that we're talking about. In order for this GitOps things to work the way we're talking about it with declarative infrastructure, we don't want to be dealing with the differences between Node.js, Python, and Go. We want to have a normal, consistent object or artifact to deal with. Let's go back to the diagram really quickly. Notice this container registry component. That's the key to normalizing your workflow across all your applications. So what's the contract between you and the developer? Well, as the developer, your job is to write code that works. Ideally, it's secure as well. And then if you do that, we can automate the process of building those Docker files. So it's on you to put a description of how to build your app, right? And then when it's done, you can actually create that entry point so we know how to run it. So how do we automate this? Well, GitHub has a really nice feature. So in GitHub, you can actually do something pretty neat. You can set up some actions, basically. So when I push to this repository or tag a branch in this repository, it'll kick off a set of actions. And they have all of these nice little blueprints that say, hey, whenever code is checked in here, push to some repository. Before my talk, I was producing a few versions. I have a V1 tag and a V2 tag. And with these releases, just by doing the normal Git operations that I tend to do when I'm writing code, well, I can rely on GitHub Actions to take over that commit, and then it will go through and actually build my image for me and push it to a repository. Does all of this in the background every time I commit or tag something. And then once that's ready, the important part here is you want to push it to a central repository. If you haven't been paying attention, GitHub also has a new container repository. So you can manage packages for all your repositories. Look here, this is a Hello Universe Docker repository. Now, if you're new to this and you're not quite sure how that all works, just know that each of those tags produces one of these container images that I can either pull locally on my laptop, something like Kubernetes, or some serverless platform that supports containers. Now that we have a repository, let's pop back over to that diagram. Again, I don't think this has to be as complex as a lot of people make it, at least not the fundamentals. So now we have this part of the loop established. Checking in our code and making container images. Got it? So at this point, we're now ready to start releasing our application to something like Kubernetes. Now, how do you go about that? Well, you can do simple ops. And what ops looks like is, in this world of the declarative world, is ops is about writing YAML files. Yay! One time for the YAML files. You'll learn to love YAML, I promise you. And if you have like VS Code and any of those robust editors, it will help you write a lot more YAML. So don't worry, YAML is your friend. What does that YAML stuff look like? I'm just going to show you one. Here's a deployment file. Really, the goal here is you to articulate what you want the system to do. I want to deploy this version of my application. I want this much memory and CPU. You get the idea. But ideally, you can have tools that help you generate these configs. They're very explicit. But the whole point here is that they're declarative. We're not writing any scripts. We're not using any custom languages or any custom tools. We're just crafting some data. The nice thing about this data is that we can push it to any Kubernetes cluster that we want. And the goal is between the deployment object and the service that allows me to attach this to a load balancer and a horizontal scaling config, I have the three components that I need for dealing with my infrastructure. So how does that work? Well, there's a bunch of things you can do here. Let's go back to the diagram. In this diagram, notice one thing that I like. This idea of splitting out the config repo from the source code repo. And a lot of people are like, oh no, you want to keep everything together. I don't think you want to do that. When you get to day 2 and day 3, there's going to be situations where all you want to do is modify the config and then push it. In those cases, you may not want to have a very complex build process that has to know the difference between a config change or the app itself. And then it gets really tricky when you start to deal with multiple environments. That one set of configs may not work well across multiple environments, especially over time. So if I were you, I would consider following this pattern, this blueprint. Keep your config repo separate. So what does that look like in the GitHub world? Well, you probably know what this looks like. If I click over here to my GitHub tab, I just have another repository where I'm storing all of my configs. And here I can have my same Git flow. I can do pull requests, I can review them, and all of my configs are just sitting here underneath this directory called Kubernetes. I can have other deployment targets. Maybe you're using a serverless platform like Cloud Run. And in that case, you may have another directory of declarative configs that you put there. But the goal is these are just all data artifacts that can be consumed by some other system that can actually take your declarative thing and make it work. Now let's pop back over to that diagram. And one thing I want you to pay attention to is you have two choices here. You can have something push these configs into your clusters, but I want you to think about that for a second. Push versus pull is a debate that goes back a long time. Not sure it's settled. But the idea here is that when those configs are ready, that's when you want them to go to your target. If you have lots of clusters, one model may work better than the other. One thing I like to do is give myself the flexibility to have different Kubernetes clusters have different versions of the config, even at the same time. Let's see what that looks like in practice really quickly. So I have a couple of live clusters running in my infrastructure. I basically have something in US West 1, US East 4, and I have another one in US West 1 in the B zone. Now, what I'm going to do is I'm going to treat this second cluster in US West as my canary cluster. Now, this is where things get a little interesting. I'm going to go with the pull model. I'm using a tool called Config Sync, and there's other great tools out there, some made by Weaveworks and many others. The choice is up to you. They all have different feature sets. Pick something that works. But the fundamentals are roughly the same. We want these clusters to link to our configuration repository. This is the core premise to what we're doing. We want these artifacts to work. So here's the other thing we want to do. I want to leverage multiple branches. That way, maybe I want 1.0 deployed to all of the clusters. And when 2.0 is ready, maybe I tell just one cluster that it should be running the 2.0 version of my configs. And we'll see what that looks like. All right, so let's see where we are. At this point, we have everything set in terms of our config. I have a command line tool called Nomos, which is part of the command line tool that allows me to interact with the config sync repositories. So what I'm going to do now is going to run the Nomos command, and I'm just going to get the status of my current deployments. So if I run the status command, it's going to connect to my clusters and tell me the current status of the repositories that it's been syncing to. While that's running, what I'm going to do now is run that curl command again. And you'll notice that we're hitting our universal URL. And that universal URL is pointed at all of my Kubernetes clusters. I have a load balancer sitting here. And that load balancer is pointing to 3 different clusters. Hello Universe is pointing to all of those zones. Here we go, down here. So with that, if I hit the global URL, I'll be routed to the cluster that's nearest to me. So if I run this command here, we should be getting the 1.0 version. If we look at our syncing, we'll see that all three clusters, US West 1, A, and East, all of them are syncing to the 1.0 branch of my Hello World universe config. And they're all in sync. And I'm getting the right version. Everything's working nicely. So now I want to make that change. Well, of course, you update your code and you go back through the flow that you're used to, checking your code. And then what will happen is a build process will kick off, drop something in your package repository, give you a new tag that's eligible for deployment, and then all you have to do is make a change in the config repository. Now, there's ways to automate this, but I just want to show you how it works underneath the covers. Your goal is on that separate branch where those configs live. Well, those configs, I'm going to show you the diff really quickly. If you look at those configs on this second branch, there's only one small change. And the change here is just to that deployment artifact. If you look here, I just went from 1.0 to 2.0, and it's sitting in this branch ready to be released. So how do we release it to the cluster? Well, there's one thing we got to do here. When I set up these clusters to pull from that repository, I did a little bit of work ahead of time. I have this config management directory. And if you look at them, they're currently all the same. But let's look at the one that I've deemed our canary cluster. So what I've done is I have a separate load balancer that's sending traffic only to one of these clusters. And it's called Hello Universe Canary. If I click on that, you'll see I have its own IP address, its own set of domain names, and it's only pointed to one of my clusters, US West B. Now is we'll hit that endpoint, and I'm going to show you the last step that you have to do as I wrap up this demo. So we'll do curl, and this time we'll throw canary into the front of this. So we'll say canary.hellouniverse, and we'll get the version. As expected, we're getting 1.0. Now I have those stages changed. I have the containers built. We only need to do one more thing here. We'll update the config management config just for that one cluster. So we'll say USPS West 1B, and we'll come over here and say, look, I want to sync instead of the branch 2.0, 1.0, we'll change it to 2.0. And then what we'll do here is we'll tell that cluster that it should reprioritize where it's pulling config. And the way we do that is we run a command. So I'm going to be talking to specifically that cluster in US West 1, and I'm going to tell it to grab that new config. We're reaching that last mile now. If I push this config up, what will happen, and we'll pop back over to the diagram. Once this config is in place, that Kubernetes cluster will go to that new branch of that config repo and then try to update the state of the world based on those configs. The nice thing about this workflow is that developers can keep checking in code and tagging releases, and then those will flow into the container registry. Only when the config repo is updated specifically for a specific environment will it go and pull the right container at the right time. So for most people, once you get this stuff set up, you end up working like you were normally working. Now you kind of have this GitOps workflow on both sides. You can start to diff, review changes, merge them in. So with that in place, one thing we're going to do now is going to run that nomos command one more time. And what should happen is I should see that second cluster or that canary cluster starting to sync. If I go over here and look at the cluster output, we'll look at our workloads, and we should see Kubernetes hard at work trying to replace some of those old versions of my app one by one, or how I direct it based on my controller that's doing the work inside of the cluster. Remember, everything's declarative on my side. I got a few more pods to go. We'll hit refresh here to see if everything is up to date. And we have one more that we're shutting down, but so far it looks like everything is green and we're ready to test. So let's see if this works. We'll go back to our command line and we'll hit that canary endpoint again. And we see it's on 2.0. And just to be sure that everything is working, we'll hit the global load balancer. And ideally, we're going to bounce around to various endpoints. But since I'm closest to this particular zone, I'm still getting 2.0. Now, there's many ways you can go about this. Maybe use GitHub Actions to validate those configs before you put them into a branch. And then maybe you automate the process of grabbing the latest container version from the container registry and updating the configs. So with that, I'm going to stop the presentation, and hopefully you have a better understanding of how GitOps works. There's a lot more you can do here. We just scratched the surface. A lot of people are looking at this as a very complex thing, but remember, you already know most of the workflows. You've probably already been working this way. It's just about combining these two things and understanding the little catch here is declarative infrastructure like this really requires something that can manage the full life cycle of your apps or your databases. And with that, I'd like to end the presentation. Thank you.